have to be fixed before you can enter play mode. So that's the nice thing. Like you'll notice it won't work, but you've got to track it down. And that's why breaking code into small pieces and just doing this debug log is important, because you write too much, then you've got to find it and track where all is happening.
It can be very frustrating, especially when you're first starting, because just something that simple is so easy to leave out.
Yes.
If you have a whole page full of code and you're getting errors, it's very hard to find within those lines of code where did you leave off a parenthesis or a semicolon. Those things are so easy to miss.
They're so easy. So take your time.
It can be very frustrating.
And when you're starting out coding, avoid copy and pasting.
Yes.
One is best practice just to learn as you're teaching yourself how to type. But two, you might accidentally miss a semicolon or parentheses, and everything's going to come crashing down around you. So
just because of one tiny little thing.
So when you're starting out, just remember it's best practice to not copy and paste and just take it small chunks of time. So we fixed it. Now let's just see if what we've written actually works. So I'm going to hit the play button. The ball's going to fall on the ground. Now, what we're looking at is we're looking down in here. If my code works, as soon as I hit the up arrow key, I should see my little sentence. So here we go. Oh, it's not. So one thing that we have to do, and I kind of pulled your leg on this because we knew this was, is once you write the script, we have to actually put it into the scene.
Yep.
So what we're going to do is we're going to go to our sphere. We have it selected here. We have to add the script to that ball so that it can now be run and processed. So what I'm going to do is I'm going to come here to scripts, and I can see one of my scripts has movement controls. I'm going to add that on there, and now, moment of truth, ball's there. I hit the up arrow key. Ta-da! And what this says is pressed up arrow key. It's exactly this same sentence that I wrote, just showed up to me here. That's fantastic.
Looks like we have a question.
Okay, so we'll pause for a quick question. Are there any game development programs for Python with physics? Or I know Python, or if I know Python, we'll know this code too. Python, real quick, can be integrated with games. Not Unity per se. Most of the major game engines, which there's the Crysis engine, there's the Unreal engine, they have their own languages. Do some Google searching on that. I haven't done a lot with Python. There is something, but Python's not generally used a whole lot in video game design. It's usually C#, C++, JavaScript, and then these kind of other programming languages that are unique to only certain engines. So, but great question. All right, so hooray, we have our thing, pressed up arrow key, and we're good. So now we are safe to move forward, and what we're going to do is we're going to add force. So we're in the physics engine. To move a 3D object, we have to apply force to get it to move. So there's going to be a couple new things that you're going to learn here. So the first thing is, to add force, we have to type in what's called game object. Now, game object with the small g, you can see how it's like, this is actually called what's called camel case. Yes. So camel case is like if I say, I saw the dog running. That's called camel case. So basically no spaces, because a lot of times computers and programs don't like spaces, but you capitalize each new word, but the first one's not small. This first part of the code says, game object, look at myself, because remember, we attached the script to the ball. So it's saying, okay, look at myself, game object. And now that I have it looking at myself, I want to get a component. So get component. And what Haley was describing is when we look at this sphere, this sphere actually has 1, 2, 3, 4, 5, 6 components. It has a transform, sphere, all that kind of stuff. We want to get one of these, and the one that we want to get is what's called the rigid body. That's the thing that Haley added that actually gives it momentum. So we need to get that component. So we're going to get component. I'm going to type in rigid body. Don't worry about the syntax here. And syntax, if you don't know, syntax is just essentially how you write something. And a lot of nice things about used programming is this little pop-up that just showed up on my screen. It's kind of like code complete. So it shows you what options you have. And I'm going to add force. And basically we have to give it a 3-dimensional direction of where this force is coming from pushing on the ball. So what we have to do is we have to create something called a vector 3. I don't know, does anyone familiar with the term vector 3 or anything like that? So vector 3 essentially is a set of data that includes an x coordinate, y coordinate, and a z coordinate. That's why it's vector 3, x, y, and z. A vector 2 stores two. It stores an x and a y. So when you're designing a 2D game, you're going to use a lot of vector 2s. It's an x and a y value. In 3D, you're going to use a vector 3. So we have to create a vector 3, and this is how you actually create a vector 3. So we're going to have to do it right above here in the start. I'm going to type in private. And what the word private means is that what I'm about to create is a container. So luckily I have my water here. At the top, what we're doing here is we're declaring our variables. We're saying this is what we're going to use in this, and we're just creating an empty shell. So, and if it's private, only things in this script can see this. So if you have another script trying to look in here, if it's private, it will not see it. Generally, for a rule of thumb, if you don't know it needs to be public, make it private. And then if you come across in your programming down the road, you can switch it to public so they can talk to each other, but private. And I'm going to create a new vector 3. That's what that next statement means. It says I'm going to create a private vector 3, and I'm going to call this force direction. If I could type correctly, force direction. So what I have just done, I've basically created a container called force direction, and it is expecting what is to go inside of it. It has to be a vector 3. It's basically waiting for me to give it some number, some that kind of stuff. So we need to give it we need to fill it with something.
With an x, y, and a z.
Yep, we need to fill it with an x, y, and a z. And how we do that is we're going to say force direction is equal to, one equal sign means I'm assigning it. I am assigning force direction. We have to give it a vector 3. So how you do that is you write new vector 3. So we're basically saying force direction is equal to a new vector 3. And basically now we've got to give it an x, y, and a z value. So I believe in our demo, the direction I want to apply force in, because I'm looking here in the scene, is going to be the z. The z is running the blue arrow here on the sphere. That's the z. So I do believe that's going to be our up and down. So out of these numbers, this is x, y, and z. So let's just say I want to apply 10 units of force in the z direction. That's what the force direction is. Now, this F is kind of interesting. Does anyone know the difference between what's called an integer and a float? I'll give you a little bit of time to do that. And we have a question. Why would you make it private? Integer and a float. What's the difference between integer and float? I'll give you a hint. This F stands for float. F stands for float. And you would make it private essentially so you're not, when you're writing a lot of other code, if everything is public, you're going to just see everything. And it's going to be super hard to find what you're looking for. So private just kind of keeps it, if you don't need it in any other script, make it private. So if you're only going to use force direction, like in this case, force direction we're only going to use in the movement control script, make it private. But if I use it somewhere else, I can come back and switch it to public anytime. All right. So a float value integer. Integers are whole numbers. Do we get that?
Decimal.
Yes. We're on to
Yes.
something. So integers are whole numbers. 0, 1, 2, 3. They could be negative, -1, -20. Whole numbers, no decimals. That's called an int. A float value is a number with a .0 or whatever after that. So what you do when you're coding in C# and Unity as well, you need to specify that this 10, if I just do 10, that's an integer. And if I do an F, it's a float. Now, integers mainly all the time, because a float can be an integer, I guess, per se, and a float. You generally always want to use just floats for decimals. Computers like that better. So the F basically says this is a 10, but it's a 10 float. So it actually has a 0.000 to it. Yeah. So now what we need to do is, now that we're going to apply 10 units of force direction, we got to see this thing what we had here, add force. The first thing we need to do is feed it a vector 3 of the direction of the force, which we just created. So we're going to give it force direction, and that should do it. So this is another moment of truth. So this is where you're like, okay, I think everything on the screen here makes sense, and now it's time for the real deal to happen.
Yes. You pray when you go into Unity, you don't have any of those little red exclamation marks.
Yes. So first thing, we're going to launch Unity, and we always check our console down here to make sure there's no errors, and luckily we don't have any errors. So
first step is great.
First step's good. So now we're going to hit the play button, and let's just see if we can get this ball just to push forward, up. Yay, there it goes. And he's going to fall off into infinity. I can switch to the scene view, and I think he's probably still... Oh, he's gone. Oh, there he is. There, way. Yep, he's falling out into infinity. So
every time you press that up arrow key, you got 10 units of force being applied to it.
Yep, we got 10 units of force being applied to it. So, but you can see it's kind of slow. So what if I want to change it? Well, that's actually someone in the questions asked, why would you make something public or private? Specifically with Unity, watch what happens. When things are private, I have to change, like, if I want to give it more force, I want to maybe change this 10 to a 50. I'd have to come into the script, find it, but you will find that your scripts will get incredibly long, and it's going to be hard to find these kind of things. One thing that you can do to make things speed up is if you change it to public. So I'm going to change this to a public vector 3. When I go into Unity, watch over here. Something's going to pop up. You can actually see, I hope you can see it, force direction, X, Y, and Z. So what making it public in Unity has done is I can actually edit this piece of code right inside of Unity. So it's really easy for me to test. So I want to say, instead of 10 in the Z, I want to apply 40. And I can just hit the play button. And let me hit the up arrow. And... Oh, ha. I was like, what's happening? This is debugging.
Yes, another key problem.
Another key problem. So let me just show you what happened. So here I have 40 typed into the Z. I hit the play button. I thought I had set it to 40. I hit the up arrow and it's giving me the exact same result. And I'm like, why? Well, if you look over here while we're in play mode, it's all of a sudden switched to 10. That's because code is never wrong. You're wrong. And so when I look here, what we're actually saying is even though I set it to 40 before I hit the play button, as soon as I hit the play button, this piece of code sets it back to 10.
It will do whatever's in the code.
Yes.
Not what's in Unity.
Yes. So one of the things that we can do, since we now that we're setting the force direction here instead of in the code, we no longer need to set it to a value. So I can either just simply delete the line, or if you're not sure if it's going to stay there, if you do a // that's what's called a comment. That means that the computer is going to skip over that line of code. And so I'm just going to comment that out, and anything on this line the computer won't see. And now let's see if my 40 will apply and we'll get some more momentum going. A little bit. Wait, it's still 10. All right, another great tip.
Yep.
There's a little circle. I did not save my script. Make sure you save your code before you run it, and otherwise you will not get the results that you expect. So now, for the final time, let's see. It's definitely 40. Oh, okay. Yeah. It's definitely faster. Yeah, I just got to keep pressing, and it's definitely... If I want to even make it faster, one thing I can do is I can actually multiply force direction by a certain value. So what I can do is I'm going to create an float value. So I'm going to create a public float. So remember, a float's a number with a decimal trailing at the end. I'm going to call this, what do you call momentum? I'm going to call it momentum. Momentum. Oop. And right here, if I just take force direction times momentum, this should really speed some crazy things up. So now if I go back to Unity, I'm going to get momentum also over here. You can see momentum showed up and I've got a 0. So I'm applying it into the Z, and momentum, I'm going to times it by 5. Let's just see what this does. There we go. Yeah, he's moving a lot faster now. And there he goes.
Off the edge.
Yep, off the edge. Awesome. So, happy news. We actually have the first key done. Now we just got to get the rest of the keys and we shall be in good shape. So, we're basically, and like I said, we're not going to copy and paste. There's our if statement. So, this is going to be repetition. So, hopefully it sticks in your head. If input dot get key down. You can see all these wonderful code completion things that do help you out while you're coding, so you're not completely key code dot. Let's do the left arrow. Okay, and then basically, so if we hit the left arrow, do this, and we're gonna basically do the same thing, but I think the left arrow actually is gonna be kind of interesting.
What angle we have to take it at.
Yes, we have to look at what angle because I don't think it's perfectly on one of the axes. Get component, rigid body. So basically we're looking at the game object, we're grabbing that rigid body component, and with it we want to add force. And we need to create a new direction. Yeah. So force direction. I'm going to rename this to up because we're going to need another
Up
vector
and
too.
down.
Yep.
Yeah.
And once you rename something, you got to make sure you go through your code and also rename it.
When it shows up red in the code, that means it's messed up.
I don't know if you can